In the last couple of videos, I've been using mostly arrays to demonstrate side effects and to discuss mutable and immutable instances, as well as deep and shallow copies. Now I want to focus on collections rather than arrays and talk about issues unique to these types. I've created a new project called Unmodifiable Collections. For this session, I'll create a class called Student. I'll add two fields, a string for name and a string builder for student notes. I'll make both private and final. I've said before that when we use the final modifier, we need to initialize the fields. I'll be talking about alternate initialization methods later, but the usual method is a constructor, and I'll generate that here with both fields. I want getters for my two fields, so I'll generate those. I'll generate a toString method with both of these fields. Okay, that's my student class, and now I'll get back to the main class's main method. First, I'll create a couple of string builder objects, one for Bob's notes, and I'll just create an empty string builder. I'll set up Bill's notes with a note that Bill struggles with generics. Now, I'll use these to create my student instances. First, a new student named Bob, and I'll include Bob's notes. Next, Bill, and I'll pass Bill's notes this time. I want a list of my two students, so I'll set up a new array list and pass that my two students using the list.of method. And I'll just print my students out, including a separation line. Running this, there shouldn't be any surprises. Next, I'll insert a statement after I create the list, but before I print the information, appending some information to Bob's notes. I'll add that Bob was one of my first students. Running this code now. You can see I successfully changed Bob's information several lines after I created the instance of Bob. This, by definition, means student is mutable. Hopefully you know how to fix this, making a defensive copy in the constructor of student, but right now I want to leave it like this. I'm going to create a copy of my student list. I'll do this by simply creating a new array list, passing the previous list to it, list of student, I'll call it student's first copy, and set that to a new array list, passing student to its constructor. I'll copy the last two statements where I'm printing students and paste a copy just below. I'll then change students to student's first copy. If I run this now, again we see the same behaviour. Bob has notes in the copy as well, even though I made my copy of the list before I made this edit. Passing a list to a constructor of a new list isn't going to perform a deep copy of your elements, it's a shallow copy. But doing this gives you a list that you can edit, adding new elements or clearing elements, so it's a modifiable list. I'll add a new student to the student's first copy list. I'll pass a new student instance with Bonnie as the name and an empty string builder for notes. If I run this code now, my second list has Bonnie, but my first list is unchanged. But again, because student isn't immutable, I can change Bonnie's notes after the construction of Bonnie, and this change will affect the list. I'll set up a new string builder variable called Bonnie's notes. That gets assigned notes from the third element on the copied list, so this is Bonnie's notes. I'll make a change to this local variable and append a note that Bonnie is taking 3 of my courses. Running my code again. You can see this note is part of my Bonnie object in my second list. To get an unmodifiable collection, I'll use the list.copyOf method. I'll set up another variable, student's second copy, and assign that the result of calling list.copyOf with my students list as an argument to that. I'll again copy and paste the last two statements, and I'll change student's first copy to student's second copy. And running this code again, you can see I again have a copy of my first list. There's a very significant difference between student's first copy and student's second copy. I'll copy the statement on line 20 and paste a copy directly below it, changing student's first copy to student's second copy. This code compiles, but if I run it, it throws an unsupported operation exception. For an unmodifiable list, I really can't make any modifications to the list. For example, in addition to being unable to remove or add elements, I also cannot reassign an element. I'll modify that last statement. Instead of adding Bonnie, I'll try to replace element 0 with this new student. running this to confirm what happens. I get the same exception. I'll comment that line out. Next, I want to try and sort my students in this copy. I'll pass a comparator since student doesn't implement comparable, and I want to sort by the student name. Once again, running this. I still get an unsupported operation exception, so I can't even sort an immutable collection. You might have noticed the package name in the stack trace, java.util.immutable collections. This behaviour and these errors would have you believe that this copy of the list is immutable, but in truth, I did mutate data in one of the elements, the notes on Bob. Although the unmodifiable list prevents many alterations, it can't prevent all the data from mutating. If the element itself has mutable fields, code can get references to that data as I've shown you in this example. It is very important to understand that unmodifiable collections are not immutable collections. They become immutable collections only if the elements in the collections themselves are fully immutable. They are collections with limited functionality that can help us minimize mutability. You can't remove, add, or clear elements from an immutable collection. You also can't replace or sort elements. Mutator methods will throw an unsupported operation exception. You can't create this type of collection with nulls. I want to change that last statement from sorting student's second copy to student's first copy. This code runs and you can see the second list is sorted by name. There's one more method I want to look at in comparison, and that's the unmodifiable list on java.util.collections. I'll set up a list, student's third copy, and assign that to collections.unmodifiable list and pass it my students. Once again, I'll copy and paste the last two statements in my main method, this time changing student's second copy to student's third copy. Running this code now. My last list looks just like my first and third, so it's an accurate copy. Now let's try a couple of operations on this copy. I'll uncomment the line on line 24 and change student's second copy to student's third copy. I'll run this. And here again I get an unsupported operation exception. Is there any difference between this copy and the one I got back from calling copyOf on list? Or is it just a legacy method on collections you don't need to care about? Actually, there's a significant difference between what you get back from these two methods. I'll again comment that last line out. I'm going to add Bonnie to my original list here next. I'll insert this before I edit Bob's notes. And I'll call out on my students list the original list, adding Bonnie. Now running this code, what do you notice about the last two lists in the output? One has Bonnie and one doesn't. When we use the copyOf method, we get a copy of the original list. This means changes to the original list aren't going to have any effects on our copy. Again, that's with the caveat that the elements are purely immutable. That aside, you can see that adding Bonnie to students did not add Bonnie to student's second copy. We manually added Bonnie to student's first copy another copy earlier. But the last list, the list we got back from collections.unmodifiable list, student's third copy, has Bonnie in it. This method doesn't return a copy, it actually returns a view, an unmodifiable view of the backing list. This list, student's third copy, is always going to reflect what's in the students list, but I could pass this view to consumers. This feature creates a kind of window, if you will, to the most current state of a list without allowing a client to modify it. In other words, you can pass a reference to a mutating list, but prevent changes through that particular reference. Let me show you a slide now with the unmodifiable collections available to us. The three primary collection interfaces, list, set, or map, have methods to get an unmodifiable copy on the specific interface related to the collection type as shown. In addition, the java.util.collections class offers methods to get unmodifiable views as shown. These methods allow us to get closer to the ideal of immutability if it's needed. In the next video, there is a challenge for you. After that, I want to revisit constructors and initialization of instance fields. See you in the next video.